So welcome to yet again another session. So today we'll be going into Ethereum, the world computer. So we'll just understand the core concept of what Ethereum is before we actually dive into running the nodes. So hint, next week would be, I said next week, this week we would actually be having live nodes, and yeah, I'll turn on my camera and show you some setup and also the hardware and all that fun stuff. So yeah, Ethereum, the world computer. Let's dive in. Yes, so let's get into the main business for the day. So Ethereum, the world computer. So we would understand the core functionalities and yeah, behind the scenes, what actually works. Let's go into the next slide. So before we do that, let's just have a recap for those that are just joining. You have not really missed a lot because yeah, this is just day 2, so you're still in the loop. If you're just joining, you're still very much on time. So last that was Monday, we discussed what is blockchain, types of blockchain, decentralization, and some key terms. So blockchain is just what a distributed ledger that records transaction across many computers. So it keeps the should not okay like something like a duplicate here. So you can't actually change it. If you change the one on your own system, you can't change the one on every other system. It's just like the analogy we made with the ShopRite, where you have different books and then the transaction you write, that is, if you sold 2 shoes, 5 shoes, popcorn, you get to write those things down. Those are transactions. Then when you write them on your book and then also on the system, probably the cashier, the manager, the clerk, they all write down what you sold for that day. So that's just how the blockchain is. So we have public, private, and consortium blockchain, which public, Ethereum, Bitcoin, Solana, private, these are can be operated in the hospitals and consortium banks. These are shared between different organizations. For private, only one organization actually runs that. For the last one, 2 to 3 organizations could decide. So there's limited access to it. But the public blockchain, it's open to anyone. We have decentralization, the benefits and the importance. So there's no central entity, no censorship, and what has been done cannot be reversed on the blockchain. Key terms, we have blocks. These are they store, like, they keep the transaction. So for you to have a block, you need 4 transactions. So that makes up what? A block. So it's just like the book where you keep writing your record. When it fills up, you get another book that is linked to that previous one. You keep writing it, you get another book. So that is a block. And then what you write into it is what? The transaction. Then the node is the whole computer which takes record of that thing. So that is what the node is. Immutability means it can't change. So consensus means there's an agreement to which those things have to be done. Is it proof of work, proof of stake, and other type of consensus mechanism? So that was what we did last week. There's a whole lot more. There's the video if you wish to go through that. We went into it like detailed, and yeah, so that was what we did last week. And then let's now dive into what we have for this week. So today's deep dive into what Ethereum. So we'll be looking at what is Ethereum versus Bitcoin, smart contract, dApps, EVM, the engine, Ether, fuel for the network. So it's just like gate fee. I'm sure some of us are in Lagos. When you get to toll gate, you have to pay a fee. So we'd all explain that, and yeah, why sometimes Ethereum can be so high, and then why do we have layer 2s? What's the difference? How did they do it that they are a bit cheaper or very cheap? Not bit, they are way cheap. Then Ethereum history, just a brief history, and Ethereum's ecosystem, the future of Ethereum. Then we go into our Q&A session. So this would be the agenda for today. So, ladies and gentlemen, join me as we begin the journey. Put on your seatbelt, have your cup of water, and your notebooks. Yeah, please keep that in mind. So let's go into it. So one rule I usually work with is if I'm moving too slow or probably too fast, feel free to either make me speed up or make me go over a concept that probably you don't understand. Just anytime in the call, just feel free to do that. I would love to do that and go back, explain. And if you have any question after any explanation, you can just raise up your hand or unmute yourself. I would listen to you. And then, so let's make it interactive. Let's communicate. And yeah, at the end, we all have an understanding of all these things that we have listed here. So let's go into the next slide. Yeah, Ethereum, a decentralized what platform. So what is actually Ethereum, why, and all that. So this would take me into a little bit of a history about it. Ethereum, I think for me, I usually see it as like, since Bitcoin rejected what they said, the stone that the builder rejected became the cornerstone. So if I mixed up that state, forgive me. But yeah, Ethereum, a decentralized world platform. So this actually came to existence because the offer was also made to Bitcoin. I think some time ago, I read and watched some videos where Bitcoin would have had smart contract and all that. But yeah, Bitcoin is not that smart, but at least you can't say something with that high amount of value is not that smart. So Bitcoin is smart, but it does not have smart contract. Yeah, that's the difference. So open source platform, Ethereum is an open source decentralized blockchain platform. So every code, every single thing, the Ethereum community loves open source project. So it's open source. All the EIPs would get into that, CIPs, every other thing in the Ethereum blockchain is open source. Beyond cryptocurrency, more than just cryptocurrency, it's what the foundation for what building application. So let's see. Okay, what is actually Ethereum? It's not just money, because sometimes we'll be like, yes, there's ETH. Yeah, that's the currency. That's the gas fee. Yeah, but it's a larger what application. It's more than what you see. It holds a lot of things. So it's the internet for us in the blockchain space, and everyone can use it, but no one can break it. So that's the idea behind it. I hope we're flowing. So enables what programmable money and programmable infrastructures. On Ethereum, you can mint money. Like there are so many Uniswap, 1inch, so many tokens. All were made possible because of what Ethereum. So this give room for what programmable money that you can just write code and then you have it, and you have it backed by other currencies and whatnot. So it's like we're taking what we have in the real world to what the internet, and then having those things stay there for what forever. So we have global computer, a global shared computer that's resistant to censorship and downtime. So what this means is that Ethereum as a whole is being run on different computers. So that is the node, and that's why we are here, but we'll get into that. So there are different computers that are connected to each other. So when one goes down, that does not mean the whole network. You don't break, they are not connected in circles so that when one goes down, there's a loophole. No, they are interconnected. So everyone is connected to everyone. So when one goes down, because everybody is connected to everybody, you would not even notice that, okay, someone just left the network. Because why? There are a lot of computers, and then we are interconnected. We are not just single threaded. I think if I'm allowed to use that word, we are all multi threaded. So we are connected to everybody. So if I have my node here, my node is connected to everybody. When one goes down, I can't predict, okay, yeah, this was the person that actually, no, because I'm connected to everybody. And censorship, it is resistant to censorship. So no one can decide that, okay, let's just take down our computers. No, because you don't know who the next person is. You don't know who you're connected to. And you're connected to everyone. So if you would want to take it down, you would need everyone to take down their own node, which is what? Impossible. Yep. So let's move to the next slide and see what do we have. So let's now see the comparison Bitcoin versus Ethereum. So let's see. Bitcoin is what? Digital what? Gold. So just look at Bitcoin like that. It's the digital gold for this era. Yeah, but is it that smart? It has a lot of value, so it's actually smart, but no contract. So that's the difference. So valuable and good for storing money. That is Bitcoin. Please, this is not a financial advice. Do your own research before investing so that you don't invest and then when it drops, you'll be like, oh, somebody said is nah, this is for educational purpose only. So Bitcoin is what like digital gold, valuable and what good for storing money. If you intend to hold your USD probably 1K for like 10 years, you could put that into buy some BTC and hold for the next 10 years. Who knows? I'm just saying. So then Ethereum is like what? A digital what factory. So can you see the difference? Digital gold, digital factory. For gold, when you find gold at a particular place, there's a way you dig that gold that at some point it gets exhausted. Bitcoin would soon get to that point. I don't know if I'm flowing. That is what our digital gold, because no matter what you do, you keep mining that, you keep digging that, you keep fetching from it, you keep finding more gold. At some point, that particular land, you would exhaust all the gold that is there. So that's Bitcoin, and we would soon exhaust it, which would make it more expensive. Please, not a financial advice. Do your own research. But Ethereum now is the factory. What do I mean by Ethereum is the factory? Ethereum gives birth initially in the previous slide. We said what? It is what? Programmable money. So you can print money from Ethereum morning, afternoon, night, anytime, any day, come rain, come sunshine. You can have your own coin, your own currency. You can bring liquidity into it. You could generate a lot of things. So imagine having the factory and having a piece of land that has gold. Which would you prefer? So that's for you to decide. So you just so you have to be smart for you to be able to decide either Bitcoin or Ethereum, but please do not hold me responsible. So Bitcoin are digital what? Gold, Ethereum, our what? Digital factory. Look at this to this way. Ethereum has given birth to so many tokens that have so many value, that have gotten a lot of values. So that's what our digital factory. You can use it to build things, not just to store value. For Bitcoin, we use it to just store, which currently now they are trying to shift towards that. But for now, Bitcoin, you can just store your money in as what it's a digital gold ware for storing what money. But on Ethereum, you can build. You don't need to store money on it. You can build application, build a lot of stuff, contract, agreement, where you don't trust a middleman. Ethereum would actually stand in for you. So that's the fun part about it. Ethereum. So let's look at what we have. So primary use, digital currency, store value, platform for dApps, and what? Smart contract. Programming, limited scripting, yeah, but we now have some. Let's not go into that. Limited scripting. Then we have what? Ethereum, which is what? Solidity, Vipers, and so many more. Allows for what? Complex logic. So Aave is a complex dApp. There are so many of them out there that do complex what stuff out there that are amazing and mind blowing. So we have solidity and Viva, then consensus, which is what how it works to mine and do other stuff. So proof of work, because it is gold. Look at it. When you find gold on the floor, what you do is what you dig. That's work, proof of work. You are digging, you keep digging to get to that point where you have gold. So digital gold, you have to what dig. But when you have a factory, what all you just need to do, sometimes you don't need to own that factory, but you can just stake or have shares. So that is why we have what proof of stake in what Ethereum and proof of work for Bitcoin, because that is the digital gold. But for the factory, you can decide to just invest by staking. It's as simple as that. Focus, we have decentralized secure money. Then for Ethereum, it also has the decentralized, it has secure money, decentralized programmable infrastructure. So it has all what Bitcoin has. Secure money. Ethereum also has what a lot of secure money in forms of tokens and all that. Not meme coin, please, because someone might ask me, okay, what about meme coins? Are they secure? Nah. So I say what programmable what infrastructure and secure money. Then we have analogies. We have digital gold, proof of work. You have to dig global computer and platform with what infrastructure. So this is giving us access to a wider range of what computing. We have so many platform and what it gives it gives birth to so many innovations that are mind-blowing. Then we have block time. What this means is that this is the time it takes for Bitcoin to perform what a transaction, to complete a transaction or to mine a transaction, which of them? Yeah, we'll get to find out at the end. Then we have 12 seconds faster transaction what speed. So it takes Ethereum 15 seconds and it takes Bitcoin 10 seconds. So look at the difference. How many 12 seconds do we have in 10 minutes? That's to tell you how fast Ethereum can be. So within 10 minutes, Ethereum would have done a lot of transaction, completed a lot of transaction, while Bitcoin is still trying to, yeah. So that's just what it is. Scalability, limited transaction throughput, which is this. The speed is slow. Then we have higher potential throughput with upgrades like shredding, which we'll talk about later on. And we have L2s, which also made it way more faster. Then we have community, large and established, focused on security. Then we have large and diverse. On the Ethereum ecosystem, there are a lot of communities ranging from the DeFi space, gaming space. Currently now, Ethereum now supports AI space. There's a lot of communities, so we can't mention them all. So focused on innovation and development. So every day something new comes out. Every day a new token is birthed. Every day we have ways of improving Ethereum. Every day we have layer twos. Every day we have security discoveries. So that is the difference between what Bitcoin and Ethereum. You can see that Ethereum has a wider range of what activities and innovations that is going on under the hood. But for Bitcoin, yeah, it's not still bad. But yeah, let's move on to the next slide. So because we've talked about, yeah,
Sorry,
okay,
I have a question.
okay, yeah.
It was on my question is based on the last slide. The transaction time it takes to approve a transaction or the block time. I don't know if you could throw more light on that. The block time at which it's used to add up the block or add up transactions to the block.
Yeah,
Is that what you
okay.
mean?
It is the average time that it takes to create a new block on the blockchain, which is for Bitcoin. The average time. So the way Bitcoin works is that, for blocks, previously we established that For you to create like a block, you need on Ethereum 4 transactions. So which is it? So imagine for Bitcoin, it takes 10 minutes to do that. But on Ethereum, it is just what, 12 seconds. So it's just like let me see, let me give an analogy. You decided to go to a shop, right, to get a shoe. Yes, so sometimes during delivery, when you place order, there are some services that are faster than the other. There are some that will tell you that from when you place the your order to when it is being delivered to you, it sometimes take 30 minutes or 40 minutes. While for some that are probably closer to you, it takes a lesser time for them to have it to you. So on the blockchain now, what this is actually saying is that the time it gets to create what, a block, because why we have that term blockchain is because a block has the transactions which have been done. Then for a block, what you have is that block hash is linked to the new block that is being created. So the time it takes for that new block to be created and then linked to the other blocks that have been created, which gives it that blockchain, it is 10 minutes for Bitcoin. So whatever Bitcoin does, before it has a block that links to the general blockchain, it takes 10 seconds to produce that block. It takes 10 seconds to manufacture, permit me to use the word, to manufacture that block and then attach it to the other blocks. So, but for Ethereum, what you have is that within that time, you have transactions that are being recorded in that block. Once it is completed, it is just like your notebook. When you write on your notebook, probably you have a store and then somebody is owing you, but that notebook is filled. You would link what that person is owing you to the new notebook that you have, but you did not get rid of what, the old one, so that by the time he comes, you'll be like, hey, there's proof, you are owing me from my previous record. He'll be like, where's the record? Then you would come with the old book, because why? It is linked to the other. If you have gone to big stores, you will notice they glue all their books together. As it gets finished, they get another and they glue it together. So that's how the blockchain works. So the time it takes for them to fill that book, that is what the block time. So, but because we are humans, it will take a longer time to fill that book and then get another book, continue writing, get another book, continue writing. So that is the block time, the time it takes to fill that book and then complete it. So that book now is now a block. Because why? They have filled it and now they have gotten another block, but they haven't filled it. So you keep adding transactions to it. Mr. A bought this, Mr. B bought this, Mr. C bought this. As soon as that book is filled, which is the block, you get another one. So the time it took for that is what is being referred to as what, 10 minutes for Bitcoin. So have I made justice to that? Is that clear?
Yes. Thank you.
Okay.
Sorry, I have a question.
Yeah.
All right. So during the process of your explanation, I wanted to get something clear. So, are you saying that even when a block is being attached to the blockchain, it's possible to still write it? Since you use the instance of writing into the book, even though you haven't attached it yet.
No. The only time, if you remember, I said the only time it now becomes like a block, it is when you have filled up that book. So when you are still, like for Ethereum, if you have the first transaction in the book, you have the second transaction in the book, it is not yet fully what, a block yet, because it has to complete that 4 transaction, then it now get linked to the previous ones. So these things happens very fast. So you have first transaction, second transaction, third transaction. The fourth one makes it complete. Then it is now what, a block. Then it now get attached to the previous ones.
Okay. Yeah. Thank you. I understand.
Okay. So any other question? So any other question? So the 12 seconds for Ethereum is that transactions are being written within that block very fast. So the block now gets created within what? 12 seconds. Then it get added to the blockchain. Then another one, transactions are being written to the block, which is yet to be added. As soon as it's done, it is now what? A fully, because if the transaction is not yet what? Completed, it is not yet a block because it is complete and it has the previous hash. Then we now have, then when it is verified and all those other good stuff happens, it has been validated that yeah, all the transactions here are not malicious, everything is complete, then it is now linked to the other process, and then you have it. And as soon as a block is linked, you can't reverse the process. But for a transaction, if there's a fake transaction, or sometimes you might notice for those who have used the blockchain before, you might have gone to bridge token A with token B. And then when you put in token A, nothing shows up. Somebody have what? Gone ahead of you and played with, we call it front running. So I've played with it. So your own transaction is not recorded. It is that person's own now that gets added to the block. So as soon as it gets added, no matter what you do, because it has already been added to other blocks, that transaction is now permanent. So sometimes when you do certain things in the blockchain space where you put in money and then nothing comes back, someone has done that. There are a lot of mechanism that goes into that. So let me not dive into all that. But yeah, as soon as it's being added to the blockchain, it can't be reversed. So that's the block time, the time it takes for a block to be created. And what makes up a block is what? The transactions. So let's now look at what? Smart contracts. So what are they? These are what? Automated what? Agreements. And as we can see, immutable, cannot be changed once deployed, transparent, visible to all network participants, trustless, no need to trust counterparties, self-executing terms, and directly embedded what? Code. So that is a smart contract. So you could look at a smart contract like a vending machine. I think the only time I saw vending machine was when I traveled. Yeah, but I think there should be in Lagos. Probably I've not gone to the right store to get to see one. So a vending machine is that there's no one there. What you want to purchase is just right inside the system. So all you just need to do is to select what you want, put in your money, and then based off your agreement with that vending machine, which is the smart contract, as soon as you put in your money, you have selected what you want. When you put in your money, it is what you want that comes out. But sometimes when you go to probably stores whereby we have humans there, when you tell them, okay, I need this and this, sometimes human error, it is not what you get. So what you order versus what you got. So that is what happens sometimes. That's outside the smart contract. But when you have your smart contract, look at it as the vending machine where you just select what you want, put in your money, and then right there you receive what? The product you want. So that is how a smart contract work. The vending machine does not need to take permission from anyone, or it does not need to make a phone call like, hey, yeah, someone is trying to get it. Should we allow him or not? Okay, like, yeah, get his phone number. Nah, that's how it works. So the smart contracts, it's not okay. The name smart contracts, someone will be like, why is this smart if you still have to do certain things? Or does it make decisions by itself? Is it an AI? Is it? Nah, it is just a code that is written that gets rid of a third party like structure, and then you have direct access to it. So when you're trying to have a deal with someone, Probably you don't trust that person. The smart contract can stand in between. When you have an human, the person you are running away from might know that person that you decided to bring in between both of you, and then you can now get what probably scammed or something. But the smart contract now stands in what? Because whatever you write there does not change. Both of you can see it. If it is A you all agreed on, it is A. Nobody else can go behind the scene. In Web 2, you can go in and say, okay, you signed the document. You can log in and then see that what you signed was not what you initially read. But with smart contract, as long as it is there, it cannot what be changed. And what it is trustless. Why? Because you know that if there is any change, you would get to see it. If it is tweaked, if the contract address was changed for some cases, which is would not touch that. So if the contract was changed or something, you get to see it that yeah, this is not what we agreed upon. This is not, so that is why what it is what trustless. So this is the smart contract, self-executing contract written in codes. So it is an agreement, legal document that we now have what on the blockchain. And again, remember, because this once deployed, the contract, you might be like, okay, we can change the contract, right? No, you can't. Once deployed, for you to change it, you have to tell every other person that has a copy of that contract. Because the moment you deploy, everybody on that network that is running that node gets a copy of it. So it's just like in the ShopRite store now. Imagine you go there and then your friend works there. But because the manager, the cashier, and probably the storekeeper gets to write whatever he or she sells. So imagine you get there and then you buy probably bread, and then they all recorded that okay, you got this bread for this price. Then you now decide to go and meet your friend and be like, hey, Alpha, just change this thing. Put it that I bought it for maybe 1K, and then you have to give me change, maybe 500 naira because you gave him 2K. Because they have all written it initially that you bought that bread at 1.5. You now see that it is now difficult for him to change that. So no matter how smart you are, for you to be able to do that, you would have to change what the bookkeeper, the cashier, the store manager has what written. Same thing is applied to what the blockchain. Because as soon as you deploy it, every other person on the network gets a copy of that contract. So for you to be able to change that, which is humanly impossible, you have to go to every other person running that blockchain that have a copy of that and tell them that, hey, please just change this A to C, which is not possible because first of all, you don't know who and who is running these computers. You don't know where it has gone to. You don't know which countries. And yeah, there are so many things that goes into what the node system. So that is why it cannot what be changed. So let's go into the next slide and let's see, okay, what are some of the benefits that we might enjoy with what the smart contract? As you can see, some of them are already listed here. Trust. You get to do business without being scared of someone going away with what you have. You can just use the smart contract that be like, when you send me this amount of coin money into the smart contract, you get X amount of the coin. It's as simple as that. If the person does not obey that, he doesn't get that. It's just as simple as that. So you can use this for what? So many things. It is transparent, which is also the benefit. You can trust it, benefits. It cannot be changed, which is giving you what? More security and what? Trust, which are what? Also part of the what? Benefit for having what? A smart contract. So we have you insert money condition, you select a product, output, the machine dispenses the product automatically, no intermediaries. So this is an example of how a smart contract works like what? A vending machine. So there's no third party there to either check or assess you if you are this or that, if you are coming from A or C. Nah, nothing like that. So you just get to use it. Right. So we now have advantages of what? The smart contract. Automation, eliminate manual processes and reduce human error. What this means is that if you have tried receiving money or sending money through Western Union, my God, you would hate the whole process, because you would have to go through a lot of manual processes. Sign this, sign that, come with your grandfather's middle second name, come with your there's a lot of KYC. They would ask you questions that even you yourself don't know that your parents have such kind of answers to that question. It's just insane when you're trying to do things off the smart contract part. But yeah, here we have what a smart contract that eliminates all that processes. So you just get to use them direct. Transparency, all parties can see what they contracted. Cost, reduce cost, and this is something very, very, very important. When sending money or sending a contract or trying to secure a contract from someone outside Nigeria, you would pay probably 20%. When you ship a car into Nigeria, you pay the same amount you bought it outside. Just imagine that if you ship a car worth $100,000, what you are paying to clear that is $100,000. But if you are to use what your smart contract and then do all that, the fee you would be paying for that agreement would be very low. But that is if our government decide to what make use of what the blockchain for such processes. But there are so many use cases for it. When sending money to someone, first of all, trust, speed are all what there. Efficiency is all what there. If you have tried sending money through the Western Union, the fee you would pay, sometimes you would feel like there's no point sending that money to that person, because you end up paying a lot of money for what transaction fee. But here we have it what with smart contract, there are no intermediaries. So all those fee you pay, because sometimes this Western Union gets to go through another party that goes through another party that goes through another party, then gets to someone in the US, the bank that will now get through another party, and then you have all those legal documents. Is this person working? Where is this money coming from? All that stuff what cost what money, because you need to keep verifying. But what on the smart contract, you don't need all that. On Ethereum, you just what have your smart contract, send in your money, the person what receives it. Is as simple as that. Efficiency, faster execution, and settlement of what agreement. So you don't need also what a third party. Sometimes when you want to sign transaction of the blockchain, you need certain people to be around, and then you need to pay them or settle them for being what they call it, is it guarantor or something. So, but on the blockchain with your smart contract, you don't need all that. So security, cryptographically what secured and what tamper proof. So this is also one of the benefits where you get to see that it cannot be changed, because the algorithm that was used for that, probably you signed a transaction, you don't need to be scared that okay, yeah, this would actually be changed, or someone can resign what I've already signed. Now it is what secure, because the algorithm has not been broken. They say anyone that can break, I think is it SHA-256, because when you put in X and Y, you get D. If you take D and X, you can't get Y. You can't reverse the process. So that's what I'm saying. So you just have a function that two things go in, or three things. The values you get, if you change one number from it, you get a different number entirely. So that is how secure it is. Then we have trustless what execution and all that. Parties don't need to trust each other. They just what trust the code. So you can meet anybody anywhere, but please mind you, be careful, because it is trustless does not mean you should act anyhow on the blockchain. Please, there are conditions to this. Because it is trustless does not mean you run any application that someone tells you to run or do, or stuffs like that. What it means by what trustless is that if the smart contract is good, which is one, if you have checked it, it is what transparent, which is two, and then security, it is secured. Then what you can now trust what the smart contract, which is the code, because sometimes people can write bad code, and then you end up saying but I thought smart contracts were meant to be trustless. No, you didn't check the code or the document you were signing. Sometimes when I land on some pages, my MetaMask just pop up. If I'm to click on confirm, I can't blame the smart contract or something because I've had, smart contract are trustless, like I don't need to trust anyone, I just need to confirm. No, if I don't read it, sometimes that smart contract is requesting that I send all my funds from my account to someone. It has happened to me before. So please check what you're doing before confirming that, so that you don't say, after all, the smart contracts are not trustless. No, they are. You just have to be careful. So next, let's look at what do we have. So this is the next big thing on the slide. So before I continue, please, if you have any question, or if I'm moving too fast, or you want me to go back and explain certain things, please feel free to ask now. So while I take my cup of water, please permit me to just sip a bit. Yeah, and I'm back. So do we have any question? Are we following? Am I using too many words? Am I using complex words that I need to define before using them? Please, let's interact before I move forward.
Yeah, thank you.
Okay. Yeah. So let's move into the next generation application, which is dApps. That D stands for what? Excuse me. Decentralized applications. So what do we have there? dApps are like regular applications, but they are built on the blockchain. So the term dApps does not just apply to only Ethereum. Any application that is built on the blockchain, there are so many blockchains. So any application that is built on the blockchain that is decentralized, because we have centralized like exchanges, we have decentralized exchanges. So sometimes it is being specified, but those are dApps, decentralized application. So these are applications built on a decentralized network. Be mindful of this. If you have it on a private network, that brings in censorship. So that is probably not a dApp. Yep. So take note of that. dApps, no one have control over them. Smart contract, they use smart contract for their core logic. For example, like Aave, if the UI for Aave, like that beautiful part of it, which is, okay, I'll show that later on. That beautiful part of Aave, if that is to be taken down, right, you can go to the block explorer and still interact with the blockchain confidently. Perfect. That's for probably maybe developers. You can do that. For non-developers, you can also do that. It will just be a little bit of stress trying to navigate the whole thing. So that is a decentralized application, because even if they shut down, you can go to the block explorer. That's the UI part of it, and then interact with it. Then it uses smart contract for their core logic. So any application that does not use a smart contract, or that is not deployed on, because some don't use smart contracts, some use Viper. There are so many, some use Rust like Solana. There are so many languages to write on the blockchain. So, but if it is not on the blockchain, then it is not a dApp. Censorship resistant. It is resistant to censorship and a single point of failure. What this means is that, just like what I said, is that if the UI decides to shut down, which is, I think I'm pulling that up. Aave, where are you? Yep. Let me just bring that to the screen and let's see what that means. So this is Aave. So we'll just use this as an example. So this is it. So for example, probably you visit this page and then it's not working. You don't need to panic. Whatever you have done, if it's on Ethereum, if it's on Base, you just need to go to Basescan, Etherscan, connect your wallet, and then do whatever you want to do. So this is a dApp. it is built on what? The blockchain, and I can interact with it using what? My wallet. So we'll get into that. I just wanted to show this, and yeah, let's keep cooking. So offers increased transparency and user what? Control. So sometimes you'll be like, okay, how do I trust this applications? How do I know that, okay, yeah, it is transparent? And yeah, I've not really visited Aave's smart contract to check in or do something, but because of the value locked and high top developers have used it and so many things around it, that is why I'm also confident that yeah, whatever I do on Aave, it's fully in my control because they don't have access to it. You can't connect your wallet on Aave and then they get to use your. For some of us that have used probably OPay or PamPay, sometimes your funds can be used to what? To invest and do other things, and then you get nothing for it. But on Aave, no one. You have to give the system permission before the system can now, which is not even them, the smart contract can now make use of what? Your money. So no one is directly what? Interacting or interfering with what you have on what? A decentralized what? A fully decentralized what? Application. Let me go that way. A fully what? Decentralized application. So if you connect and then you have your money on Aave, it is the smart contract that is making use of it, not someone else, not an individual. Even if it's a third-party smart contract, it is still what? A smart contract. So there are no what? Third-party humans having access to your money on Aave. So that is why we have what? Transparency and what? User control. It is what you allow that the smart contract would accept. It's as simple as that. So let's move into the next slide. If you have any question, feel free to pause me and then ask. So we have DeFi, decentralized finance. So these are some of the use cases for dApps. We have DeFi, which is a decentralized finance, lending, borrowing, trading, Uniswap, Aave, as you can see. So this is it for borrowing and doing a lot of stuff. You have what? Aave for trading, swapping your coins. You have what? Uniswap. NFT marketplace, we have OpenSea, a lot of them, buying, selling, and trading what? Digital assets. These are all what? On what? The blockchain. Not the UI, but they have smart contracts. So the UI is just the beautiful part whereby they have users interact with it. There's the other part that is not all that beautiful that you can also interact with. So it's a two-way thing. So buying, selling, trading, digital assets, etc. OpenSea supports that. We have decentralized social media platform resistant to what? Censorship. So this is, do I know of anyone? Zura, is it Zura? There are so many that are what? Decentralized, whereby you can post anything and you would know what? Be sorry about the icon, but yeah, Twitter has, you can now pay with crypto, but it is not fully decentralized. It's making use of the blockchain. So there are applications that make use of what? The blockchain technology in their stack, but that does not make them what? A fully what? Decentralized application. So we have supply chain management, tracking goods and verifying authenticity. There are so many platforms. I've seen so many projects, but just to mention them just off my head. Yeah, supply chains management, tracking goods and verifying authenticity. Imagine in Nigeria, we now have maybe the code on probably a drug. You can now copy that code and go to maybe Base Scan or BNB Scan or Etherscan, and then you just type in that hash, and then you get to see the transaction that, okay, yeah, this drug was actually what? Verified what? On the blockchain. So that is how you can also verify, or there will be a platform whereby you can put in that unique ID, then you get the transaction hash to show that that drug was actually verified what? On the blockchain. Some countries use that, but very soon we'll soon be using that here too in Nigeria. Yeah. So we have games, assets, economics using what? NFTs, Polkadot, so many of them. Like there are so many games now that when you play them, the point you get, you can mint them. Your characters can be an NFT. You can sell them out And then some of you might be asking, what is NFT? It is just, the way we have our traditional art, right? But this one is on the system, is on the internet, and it is unique, and it can be traced where the source came from. So that is an NFT, non-fundable token. So you can't duplicate it. You can have different, what do they call it? What's the word? I think the word just ran out of my head. But yeah, you can have different collection. Yeah, that's it. Different collection of that NFT. But each of them are unique. So if you sell out one, we can trace who owns that NFT and how much did you buy it. And so that was a way for incentivizing artists, because now an artist can just decide to make a painting and just have it out there. Someone can duplicate it and then claim that work belongs to them. But now that we have NFTs, it has reduced that risk and also giving artists the power to make a living from what they do. So that's just the other aspect of NFTs. So we have voting systems, secure, transparent, and online voting. So because the blockchain, you can't reverse it, you can't manipulate it. So when you vote once, it is once. You can't duplicate, you can't multiply it. So that is one of the advantages of voting systems on the blockchain. You can't manipulate it because it is immutable. The moment it is 10, it is 10. If it is 2, it is 2. And you can see the amount of people that have probably voted or not. But in the systems that we have now, you can't. All you just hear is 128564833 from this location. ACC3D4896 from the other location, but you can't verify it, and you just have to believe what you hear. But if we now have our voting systems on the blockchain, when they are calling figures, you can now go yourself and check the transaction hash and see, are those numbers adding up? Are they correct? Are they coming from this place? Are they humans? Were they multiplied? So you would actually know if it was actually played or not. So that is what a secured voting system, and it is transparent because you can see all what is happening in real time at the same time. So any question before we move into the EVM? Any questions? So we just touched on dApp. And this is also what makes up transaction. Everything you do in these platforms are called transaction. When you lend money, it is a transaction. It is written. When you borrow, it is written. When you're trading, it is written. Uniswap, on Aave, it is all being recorded on the blockchain that makes up a block, and then it now get added. Hence, we now have blockchain because they now are interrelated. So whatever you do, if it's a decentralized platform, probably you're subscribing, it is a transaction. Voting system, when you vote, it is a transaction. When you verify, it is a transaction. On gaming platforms, when you mint your character, it is a transaction. When you claim the tokens from probably your score, it is a transaction. When you buy a weapon, if that weapon is on the blockchain, maybe the weapon is an NFT and you have to use an ERC20, which is a token on the blockchain to buy that, it is a transaction. So everything this application does creates a transaction. So let's now move into the EVM, the Ethereum's computational engine. So let's now discuss. Please, if you have any question, feel free to ask, and let's move on. So the EVM is like an operating system. So just like the way we have Windows, Mac OS, but instead of running on your computer, it runs on thousands of computers. So have you ever imagined that the Windows you have here, like currently I'm running Linux. This is Linux. This Linux is not actually, my Linux here is not what is on another person's system. What that person have is his own Linux, probably different version. And then he has his own system. For Windows, you have yours, I have mine. Every other person have theirs. But for EVM is that this is being run on every computer. That is why when you check, The moment there's a transaction, they all duplicate it, not like a duplicate, but they keep a copy in the same location. So that's what the EVM is. So let's just go deep and then we'll get to understand what the EVM actually does. And yes, so runtime environment for smart contract on what? Ethereum. Execute code, run smart contract, and updates the blockchain state. So that is the EVM. It is like an environment whereby all these activities takes place. So look at the shop right now. If you remember, we said what? That notebook where you keep writing, probably the store owner keeps writing, Mr. A bought this. He writes it in the book. Mr. B bought this. That environment, that whole process where he's doing that is what? The EVM. So just look at it that way. The EVM is where everything is being carried out. The ecosystem, the atmosphere, the location. So because this is a software, it is now what? On every computer. So that is how it works. Runtime what? Environment, execute codes, record transaction, verifies, do a lot of stuff, and yeah, consistent what? Execution, same result across all nodes. So for like ShopRite, I'm sure not all ShopRite do that, but for some, they are interconnected. So when you have a transaction on one, for some, it would actually be on every other. So sometimes they might run a promo on the ShopRite in somewhere else, and then you can go with your code to the ShopRite in another location and also get access to that. So that is something similar to it. But because this is running on the whole computer, like on the whole nodes, we defined what nodes are in the previous session. So an EVM is an environment whereby all these things what take place at the same time on each and every what computer that is on that network. So same input always produce the same output. What this means is that if you take A and B and then you put it in, the hash you get is the same thing. But when you take A and C, when you put it in, you get a different hash entirely. So that is the meaning of same input always produces what? The same output. So if you put in A and B and you get a hash of 12685, if you put in A and B again, you would still get 12685. That is the algorithm, probably called Ketchup 256. That's for Bitcoin. Ethereum also uses that, and so many others. There are so many algorithms, but Ketchup 256 does that. Execute code and lots more. So let's move further and see. Yeah, so the EVM is like a global operating system. Yeah, global OS. Not think of it what as a global distributed system. It provides rules and environment for application. You can see this. So just like the ShopRite, that is the environment whereby they write the transaction of what where you bought those things. Imagine buying something in ShopRite and then you get to write what you bought on your way to your home or in front of your home. Like it doesn't make sense. So this is how it works. Where you do it, that is where everything is recorded and verified. So it manages resources, ensures consistent execution, just like an OS on your computer, but decentralized. Everybody is at the same time. Everybody is contributing. Everybody is trying to verify that Mr. A sent B this. Do you have that on node A? Yes. Do you have that on node B? Yes. Do you have that on node C? Yes. Do you have that? So this happens very fast. And it also helps in copying all what you are doing to the whole blockchain. One person verifies, but every other person gets a copy of it. So that's how it works. So I hope we are moving. So yeah, with all this now, we now have what? Ether. Why do we have this? For you to be able to do that, there are certain places that you need to go to that you would have to pay gate fees, right? Sometimes there are events that are paid. You have to like pay before you what enter. Same thing also applies here. you get to pay a little what gas fee, which is called what Ether. On every other blockchain, they have theirs. Solana, you pay in Sol, BNB, and every other one. Optimism, OP, they also accept it. So it is what the native cryptocurrency what on what Ethereum. So that's our native currency in Nigeria is what Naira. The native currency in UK is what US. The native currency on the blockchain is what Ether, which is what ETH. That is what we use to pay for what transaction fee, because whatever you do, you don't expect people to do it for you for free. So you would abuse it. That is why so many things now you just have to pay for it, even when it's meant to be free. But we are humans, we'll definitely find a way to abuse such platform. But when there are fees, you now know that for you to abuse it, you need to be like Elon Musk. But yeah, that's by the way. So transaction fees used to pay for what? Transaction fees, which are called what? Gas. Network security incentivizes what? Validators to secure the network, which is what? Proof of stake. So if you want me to like, okay, invest in your company, do this, just look at it in the Web2 aspect of it. Proof of stake, like we initially established, is what? You get to stake and then you make money from it. So imagine I gave this analogy on Monday. If you have a place where you want to work, right? And then they decide that, see, you would have to stake 100K just for us to know that, okay, yeah, you would not dupe us, you would not come late, you would not misbehave. So for each day that you show up probably at ShopRite, because you have given them 100K, that you'll be showing up every day to clean, to attend to customers. So as soon as you're done attending to one customer, to that your 100K, they add 10K. So when you attend to one customer, they add 10K. When you are being called and then you answer, you attend to the customer, they add 10K. But as soon as you are being called and then you are nowhere to be found, probably you have gone out, you went to play, you went to do something else, and then they called you, you are not there to attend to that customer, they get to remove, instead of giving you 10K, they remove 10K from what you have. So probably you have been good for like 2 days, you now have 120K. The third day, when you come and you're probably rude to a customer, they decide to take out 10K from your 120, which is 100. The following day, probably you came late, they took out another 10K. The third day you showed up, probably they called you and you were not there to answer the next customer, they took out 10K. So that is what we use what ETHs for. So ETHs is what you stake, just like the money you staked in ShopRite. And then to incentivize customers, what you get back is what? Money added back to what? The money you gave to them. So that is what incentives that what validators get. So that is just the whole ideology behind staking, validating. I just gave you like a short overview of how it actually works. So, but Ethers is just the native currency for doing anything on Ethereum. So it now says essential for what? Interacting with dApps and smart contract. Yes. So if you are going to Aave, what are you going to do? Transaction, you are not going there to sightsee or to play or to, you're going there to borrow, you're going there to lend, you're going there to sign transactions, and all those things what you pay what? Gas fees, which are paid in Ether. So just look at Ether as the currency for what? As the native currency for Ethereum. So that is what it is. And that is what is being accepted by the EVM. So for you to have access, for you to be able to send your transaction to the EVM, where the EVM now does the whole magic that we are still learning, you have to pay. And then the EVM will now decide, okay, someone just paid for us to send money to this person. So who would do that? Okay, yeah, node B, here is the fee, here is what he wants us to do, send it, verify the transaction, and all that stuff. So you just get to incentivize the miners, which are validators. Proof of work has miners, but here, proof of stake, they are called validators. So understanding what gas, the cost of what? Computation. like we said, computational measurement. Gas is a unit that measures the computational effort required for an operation. So operation cost, every operation on Ethereum, transaction, smart execution, smart contract execution, verification, and all that. If you have ever done a transaction and you were not charged, someone paid for it. There are no free transactions on the blockchain. There are only we now have payable functions whereby someone else can now pay for your gas fee. So market-based pricing, gas price fluctuates based on the network demand. User control, user sets a gas limit and gas price for their transaction. So this is not often advised, because sometimes if there is a base fee and then you decide to go below it, the network would not pick up your transaction. You are incentivizing it below its standard. So it's just like you're trying to have a work agreement with someone that has charged you. This is his base fee, and then you went far below that. He might probably not pick the offer, and then your transaction would not be successful in the blockchain space. So this is like paying electricity bills that runs on your computer. More complex programs require more electricity bill, right? So if you have your TV on, your fridge, your this, you would pay more electric bills compared to someone that probably just have maybe his TV set and his laptop. So that's it. But now we now have layer twos which are making it way cheaper. We'll go into that subsequently. So I'll move a bit fast because of our time. So let's just dive into the brief history of Ethereum. So we are just trying to understand this because we'll be diving deep into running nodes. So you need to know all these things before we get right into running your own node. 2013, Vitalik published the Ethereum white paper. 2014, Ethereum crowdfunding. Ethereum network launches. 2015, the DAO hack, a major event what mentioning. So you could also read up this and then find out what actually happened. So growth of DeFi and NFT, launch of Bitcoin chain. So initially, Ethereum was on proof of work. So we're also digging, we're also mining. You need hardwares, like complex, sophisticated system to do all that hard work for you. But then it moved to proof of stake, which you just need to stake for you to validate a transaction. Then we have the merge, the complete transition of proof of stake. So merge is the process from leaving proof of work to proof of stake completely. That was the merge. So this is just a brief overview of the whole ecosystem and what had happened in time past. So these are all major events that requires you to read up, but because we are not in a history and science class, we'll just touch them lightly and move forward. So what next? Thriving Ethereum ecosystem. Developer tools now. We have libraries, IDE, Truffle, Remix for those who are in the development space. But please do not be overwhelmed. We are just touching this part today once for all. Would not bore you with this content again. Would be going into hardware, turn on our cameras, show you the nodes, hardware, how to set it up, how to couple it up. If you decide to buy the RAM separately or the CPU separately and do all that fancy stuff. Yeah, we'll get into that. So we have layer 2 scaling solutions to improve transaction speed and reduce cost. So let me just give an analogy for layer 2s. Look at layer 2s as like, imagine when going to ShopRite, per person, like toll gate, when passing through toll gate, if we all have our cars and we want to buy something, probably there's a ShopRite that has a toll gate. So if we all go individually, we get to pay one USD each, right? So imagine we now decide that, okay, why don't we have one car that we can all get into that car and then get to the toll gate. Now, what the toll gate sees is that car. It does not count, okay, how many people are inside. So then that car gets to pay 1K, right? Then we all go in, shop, get what we want to get, then come back, right? So imagine now, if each of us had our car and we're going there to buy things, we'd all pay 1K. But if 10 of us now decide to get one car, enter that single car, would all what be bringing what 100 naira. That is why it is what cheaper. Same thing happens in the blockchain because the transaction is being bundled. So if we have 10,000 people's transaction being bundled, each of them will split. For example, if the gas fee is 100 USD, 10,000 people divide it by 100 USD. Can you see how cheap that is? But if you are to go there alone, that is why sometimes when you go to the EVM, that's Ethereum, directly yourself, sometimes the gas fee gets as high as 50 USD, 10 USD, 100 USD. But if you're going through the layer twos, which would still send your transaction to Ethereum, by the time they bundle up 10,000 people's transaction, they now split that 50 USD gas fee among 10,000 people. You'll be paying in cent. So as soon as you pay that, your transaction gets sent what? Bundled up and sent what? To what? The blockchain. So that's just a simple analogy for how layer 2 works. So they just bundle up the whole transaction, split the gas fee amongst everybody's transaction that was bundled up, and then send that bundled transaction to the blockchain. So you don't need to go to the blockchain directly. The layer 2 will do that for you, just like the car that passes through the toll gate. Then we have our wallet, software to manage ETH, interact with dApp, e.g. MetaMask, Ledger, and so many wallets, Coinbase wallet, and so many. So this gives us access. This is our entry point to what? The blockchain. You need your wallet to be able to sign a transaction, do so many things for us to be able to verify that, yeah, this is actually someone in the system, because without your wallet, you can't really do anything on the blockchain space. So we now have DAOs, decentralized autonomous organization, community-led entities governed by what? Smart contract. So this might be a little bit too complex, but just know that all what this is saying is that we now have systems and communities that are now on the blockchain that are being directed. All their decisions, all what they do is based on the smart contract that has been established in that organization. So that is what a DAO. They have to vote to do certain things. They have to sign transactions. They have to do so many things to come to agreement using what? A smart contract. So please, if you have any question, feel free to ask, and then we're about coming to an end for this session. So Ethereum's roadmap, what's next? Continuous what? Development, scalability, focus, further enhancement and increased transaction throughput. Currently, it is still a bit slow, but we have what? Layer 2 what? Adoption. EIPs, Ethereum improvement proposals, community-driven proposals. You can also participate in this. If you feel there is something you want to see on the blockchain, you can also propose that. Just read through the guidelines, and who knows, it can be implemented. So the surge, the verge, and what? The plunge. So let me see. I meant to explain that. So what each of that statement mean, so I don't get so many questions at the end. So what does that mean? Let's see. I think our time, I have 10 minutes more. So just permit me to go further, and then we'll get to explain this. Yep. So career in what? Ethereum ecosystem. We have blockchain development, code dApps, and smart contract. Solidity, which you can also write what? Solidity smart contract. Front end, the UI part, in as much as we have smart contracts that do a lot of fancy stuff, we need people that would what? Build that beautiful UI. So it's not just about the smart contract, it also involves the UI. So we have security auditing. Those are the people that after writing your smart contract, you need to audit them to confirm that, yeah, these are good, they are secure and transparent. So, and then you also get to find flows in your smart contract. Yeah, do you have any question? Feel free to ask.
Yeah. Um, My question is, what are the difference between a blockchain developer and Solidity developer? Or what's the difference?
Okay. Oh, okay. Solidity developers focuses only on, as you can see, it says specialize what in Solidity, but you can be a full stack. This is a full stack. You write both Solidity and also write probably your front end yourself. Do you understand that? But you can also be a front end developer only. You have nothing to do with Solidity. You might understand how it works, which is a plus, but you don't write what Solidity. And then Solidity developers, you only write Solidity. You don't touch React, CSS, HTML, nothing like that, just Solidity. But if you do both, you're a blockchain developer codes, and every other person, this and this are under this. So you can be you are a Solidity developer. That makes you what a blockchain developer. You're a front end developer in the blockchain where you build UI for dApps. You're a blockchain developer. But when you combine all of them, you fall under this category. But when you now decide to focus only on Solidity, then you call yourself a Solidity developer. So that is what it means. So is that understood?
Yeah, sure.
Okay. Yeah, thank you very much for that. So let's move. Okay, and also one more, which I did not add here. We now have node operators. That is also what a career path in the ecosystem. You can run nodes. There are so many career paths. I just listed the ones that are obvious for now, that is taking the whole trend and all that. So security auditing, what you do, you get to check if what this guy have written is what secure. You try to find vulnerabilities and flaws. Because we said the smart contract cannot be changed and it is trustworthy, that does not mean if you make a mistake on your end, the smart contract would be hacked. Not that how would I put it? It is the smart contract itself. No, the developer made the mistake. So this guy here, security audit, finds and fixes security flaws in the smart contract that has been written here. So does anyone have?
They have their own tools, like their work tools really that they use in doing that. Right?
Yes,
Just
they
like
have.
the way front end Solidity
Okay, yeah,
uses.
go.
I say just like the way smart contract devs uses Solidity, front end uses React. Security auditors too, they do have their own tools too. Right?
Yes, they have. There are so many, but mostly for this security is mostly you have to use. There are tools that you have to use, but most of the time it is your brain you would have to use. The business logic, you would have to understand the business logic in it. You would now try to break that logic. There are tools like how have I forgotten about? You can also just search security audit tools. You would get them for smart contract. There are so many tools that you can use. Yeah. So the Slither, yeah, there are so many. You can use this, but it all boils down to how you understand the code, the business logic, the tokenomics, and a lot more. So this is beyond tools. This is you as a developer with the smart contract, trying different things, breaking the code, testing out. What if you try this way? How do I break it? So that is how it works. So I think we're about to come to an end for this session. And yeah, key concepts we have covered: Ethereum, dApps, Ethereum history, smart contract, EVM, gas, and the future development, ongoing improvement, and roadmap. So we have come to probably the end of this session.